Let's balance the oxidation reaction using the half reaction method. So here we have copper solid. So by itself you have oxidation number of 0. So our step 1 is to identify which are undergoing the oxidation and which are undergoing the reduction. So we have 0 for any element, and the ion, it takes the charge, so +2. And here we have nitrogen, that should be +5. The reason is you have net neutral of -1, and then the oxygen atom bears -2 charge, and there are 3 of them. And then you have the oxidation number of nitrogen, which I call it X. So I have 3 times -2, that becomes -6, and -6 on the right side would be +6, and then subtract 1, you get 5. So for the oxidation number of nitrogen becomes +5. On the product side, the nitrogen over here must be +2 because it has net neutral of 0 and oxygen bears -2, therefore it has to be +2. Now we have to identify which one is the which chemical is being oxidized and which chemical is being reduced. When you see the copper here, the number increased, therefore we call that oxidation. And when you take a look at the nitrate, that becomes nitrogen monoxide, then that becomes reduced. See how numbers are reduced here. Once you identified the oxidation and reduce half reaction, we'll split them apart and then balance it out. So I'll start with the reduction. We have nitrogen, nitrate ion, and then on the product side we have nitrogen monoxide. Okay, for now I'm gonna ignore the state. We have to balance the number of atoms here. Okay, we have same number of nitrogen, so that's fine. However, we have 3 oxygen as opposed to 1. I have to introduce water. And how many water molecules do we need? Seeing we need 3, we need to have 2 water molecules to balance out the number of oxygen. And then since we are missing the hydrogen on the reactant side, I have to introduce 4 hydrogen ion, which makes the solution to be acidic. And then we have to balance out the number of electrons. So here I have a charge, net charge of +3, because 4 plus and then 1 minus. Over the product side, we don't have any charge. Therefore, I need to introduce 3 electrons. And for now, this half reaction is balanced. Now let's move on to the oxidation. Now oxidation has copper being copper ion. Therefore, I write copper and then copper ion. Now, you don't need to introduce water or hydrogen ion, and it's pretty much balanced for the element itself. Therefore, all we have to do now is just introduce the electrons on the product side. Now we have net charge of 0 on both sides. So this is balanced form for the oxidation half part. Now we have to balance both reduction and oxidation by having the same number of electrons. To do that, I have to multiply the top by 2 because we want to have 6 electrons. And how do we get 6 electrons? It's the least common multiple of 2 and 3. So to get the same number of electrons, I have to multiply by 2 for the in the reduction reaction, and on the bottom I have to multiply by 3. So distributing all the numbers, so I get 6 electron plus 2 NO3 minus plus 8 H plus goes to 2NO plus 4H2O. On the oxidation half reaction, we have 3 copper that becomes copper ion, and it spit out the electrons. Now you see that 6 electrons can be cancelled out just like mathematical equations, and there's nothing else that can cancel diagonally, so all we have to do is just add them up. So treat the arrow sign as if it's an equal sign in math, and also introduce or write down the state of each molecule. So starting with our reactant, we have 2NO minus, this should be an aqueous solution, then 8H plus should be an aqueous as well, and our copper should be solid. On the product side, we have 2 nitrogen monoxide, and this is in the gaseous form, 4 water liquid, and finally 3 copper 2 plus ion. So that's how you balance out. So this is the final answer for this problem.